Hello and welcome. Today we will be solving Leetcode 259, 3 sums smaller. This is a nice build up and continuation from Leetcode 16, which is 3 sum closest. Very good problem to work through and pretty decent foundational. And it kind of builds on top of this one in my opinion. So with that being said, let's go ahead and jump right to the problem. So given an array of n integer of nums, an integer target, and an integer target, find the number of index triplets I, j, k, with 0 being less than or equal to i's being less than j, and j's being less than k, and k is less than n. So we need to basically be right next to each other. So, I, j, and k, and we can never have something like this. J, I guess. So looks like we need to stay in a certain order, which is what this problem is stating. And satisfy the condition that nums of I, j, and k are less than the target. So we need to calculate the current sum and make sure that it is less than the target. So, and that includes also, not includes, but also to keep in mind that if we run into a situation where the current sum is equal to the target, then this would violate the base condition of being less than. So we would technically not increment or count that as being part of the triplets that count to negative, being less than the target, which is what this problem is asking for, is to return the number of triplets that summation is less than the target. So with that being said, the input is -1 right here, and 0 and 1 and 3, and the target comes out to be, we have a target of 2. So our combination right off the bat is, you got -1, 0, and 1. This adds up to -1, which is less than 2. And you got -2, 0, and 3, which add up to 1, and that is less than 2. Now, but what if we do 0, 1, and 3? That adds up to 4, which is greater than 2, and that does not count. So here we take these two, and we increment our value of a variable, and that should return us 2, which is what this output is looking for. Now, let's go ahead and jump to the board and kind of talk to the algorithm that we'll be using. Heads up, this is going to be a 2-pointer technique. Oh wow, I cannot spell 2. That's very nice. 2-pointer technique. And there's a little nice caveat to this problem that I really enjoyed learning about as well myself. So let's go ahead and jump right to the board. So I'm going to borrow the example again. So we had -2, 0, 1, and 3. I think that was it, right? Perfect. And we had a target of 2. And the output came out to being 2 as well, but I would like to kind of just jump through the algorithm and walk through, do a dry run as well. So first we need to have a pointer I, which is a for loop. That's going to start initializing everything from the start, and we have a left pointer that starts at I plus 1, and you have 3 where R will live, and R is basically the length of the array -1. That being said, here's the for loop for I. Length of nums. So while left is less than right, that means we have not crossed each other. So this is here and this is here. We have not done that yet. We are good to continue in computing the array. So let me switch colors. And we're going to calculate the current sum at each position. So nums of I plus nums of left plus nums of if current sum is less than the target, what do? We would, increment like we mentioned, but instead of incrementing, instead of just going by like +1, oh, by the way, I will have a result variable. So this is the example. So I'm going to add a, right above the for loop, a result variable, I'm going to initialize it to 0. So instead of like just, hey, we found a combination, let's go ahead and increment it by 1, right? That would be pretty cool, wouldn't it? Okay, this is turning into a mess. Yeah, so, and we would just increment our left pointer since we found something less. But a better way and a much quicker form that could give us the same answer, and the more accurate answer in my opinion, would be to just give me the distance between the right pointer and the left pointer. And that will be incremented into the result array until we find the condition where, hey, we have a situation where the current sum is greater than the target. So we want to decrement the right pointer. And if our base condition is no longer valid, we will just exit and sorry, we have ran through the for loop. We would just return result. Now, how does this really work? So let's go ahead and do a dry run. I'm going to choose white. So we get to the first position. In the first position, current sum basically at this point is okay, my pen switched to the eraser for some reason. So we are at -1, -2, sorry, 0, and 3. Now, this is a valid combination that is less than the target. It's valid, and that is 1. Now, what is another combination right here that can result us in being also less than the target? There's -2, 0, and 1. And what does that, and again, that is a plus, so that's not 11, that's just a Roman thing. So really, these two add up to being 2. 2 possible triplets that could result into being less than t. Now, what does that all have in common? They are all in the boundary of between the left pointer and the right pointer. They exist here. So knowing that they exist here, why don't we just return the distance? The distance between r is at 0, 1, 2, 1, 0, 1, 2, 3. So r is at 3, and the left pointers are 1. So given right here, 3 minus 1 is equal to 2. That is the distance between these 2 pointers in which the current sum is always going to be the target. Oh, and one more thing, which I should have mentioned earlier, and I truly apologize. This array needs to be sorted before we even get to this algorithm. So we need to have the nums, or the input array, sorted. And the reason why, and exactly the situation that we just ran into, is to guarantee that, hey, any value that we add that becomes less than the target, and we are at this boundary, we can safely and easily assume that all of the combination that exists between the right and the left pointer at that point is going to be less than the target. And that's where we would just calculate the distance, as we did here, and increment the left pointer because we found something less than the target, and append that into the result array until we come through another iteration that would result in us finding anything that is smaller than the target. And again, if we do, then we would append that, because that is another combination where, there's combinations that exist beyond where our initial left pointer was, and right pointer have been shifted along the array as well. So this is a good, really, trick to go into this. So time complexity of this algorithm will be big O of n squared, because we have a for loop and a together. Now you would say, oh, well, we have a sorted functionality call out here, right? Well, if you've been visiting and kind of doing your own research, you would quickly realize that whenever there's a time complexity of n log n, not when there is, but n log n is a lot less in time computation than n squared. So technically this gets dropped, and n squared is the dominant, and that occupies being the biggest headache when it comes to analyzing time complexity. So hope that was pretty helpful. I gave you kind of like the pseudocode of this. If you're feeling adventurous, go ahead and code it up. I think this, not really the pseudocode, but it is the code for the solution. But with that being said, let's go ahead and jump right into Leetcode and code up the solution. All right, we're here at Leetcode. Let's try to go ahead and code up the solution. So first we need to sort the array. So nums.sort, and then we would like to declare our result variable, which being 0. And let's go ahead and create the for loop. Nums. Okay, and then let's create our left and right pointer, which is your typical I plus 1, and then length of nums -1, while left is minus on the right. Let's go ahead and calculate the current sum, which is nums of I. I'm going to go ahead and copy this guy. Left. And nums of R. If current sum is less than the target, we would like to append the result, or add the result value, the distance between the left and the right pointer. So it'd be right minus left, and the left pointer incremented. If I can type. Else, we have reached a point where the current is either equal to the target or greater than the target, which violates the condition from the problem. So we're going to say right pointer, the current by 1. So we can move it along the array. If the array is done, we would like to return the result. So, excuse me. So this current sum is the same condition that is being requested by our problem. Nums of I plus nums of j and plus nums of k. The indexes need to be less than each other, while k, or the right pointer, being the greatest, the left pointer being the middle, and the I being the initial positioning. So that being said, let's go ahead and run this problem. And we've passed our local. Let's go ahead and submit this solution. And we have a nice time complexity of n squared, as I mentioned earlier. And space complexity is going to be O of 1. Yep. The reason why is because we don't have any data structures or anything. The only thing that technically we're storing is just the integer value, or the variable itself of result. Automatically, I think Python as a language, I'm probably wrong here, but I'm going to just say it. It might be that it stores it as an integer initially, or unsigned, an integer to hold positive and negative values, but could be wrong. That being said, I hope this was helpful. Please feel free to come back to the solution and drop any questions in a comment. I hope you have a best preparation and time. Thank you.